Good morning, everyone. Happy Wednesday, and welcome to the Energy Trust of Oregon's EPS New Construction Verifier call for March. We still have a few people logging in, but because we've got some really great content today, I don't want to dilly-dally around too much. I kind of want to jump in and get us started so we can get to the really good presentations. And what do I mean by the really good presentations? Well, let's take a look at what's on our docket for today. Welcome to the welcome and housekeeping section of today's presentation. In a minute or two, we'll go through some program updates and announcements. Then we'll go to the technical corner, and today we've got John Miles going to talk about Sanden CO2 heat pumps, which we're very excited about. And then Anna is going to help out on the runway and talk about energy modeling. We'll come back to me. I'll talk a little bit about trainings, some upcoming trainings we've got that we think should be exciting for folks. And then we'll end with some questions and wrap. But we really do want to get to the technical corner and the runway where I think we got a lot of really good content this week. So great. Since I've been chit-chatting, we've got another 4 people that have logged on. So I think we're good to go. Let's get to our program updates and announcements. The first thing, our annual Verifier meeting is coming up. So mark your calendars for April 7th. This is going to be a virtual call. We should be updating the calendar invite for the April Verifier call to indicate that this is a special event, and we're scheduling it for 2 hours. We may add an extra hour at the end in terms of a training. We'll see how this all pencils out, but at the very least, plan on right now at least 2 hours for this. If you remember in years gone by, it's been as many as 6 or 7 hours when we do it live. So we really are going to truncate to try and make this tolerable for an all virtual event. We're going to talk during this about the 2020 program. We'll look at some of the highlights in the year in review. We'll hear some updates from the Energy Trust of Oregon, what's going on with their residential programs. And then we'll dive into 2021 and talk about how the program is changing and what we're seeing with Washington and Oregon codes. And a lot of that's going to be on how the energy codes impact our programs and what the REACH code in Oregon and the STEP code in Washington may look like and how they may impact our program. We're working right now with ResNet on making sure we can get you professional development hours for this. So that is our intention, and we have an existing MOU with them, so it's just a matter of adjusting it to make sure that it reflects the amount of time. Reminder, we really highly recommend that all verifiers and field inspectors attend this. It really is a great chance to make sure everyone is on a level playing field moving forward. But at the very least, it is mandatory that at least one representative from all verification companies attend. If there is a reason why no one from your company can attend, please reach out to your verifier account manager, and we'll likely schedule a one-on-one and go through a lot of these details directly with your team, or maybe in a smaller setting. So please, if this is something that you find April 7th is going to be very challenging for your company, please reach out to your verifier account manager, or of course to the program, and if you forget who your verifier account manager is, and we'll direct you appropriately. So we're very excited about it. We think we're going to have a really good program for this. We'll try and make sure it stays fun and fast-paced enough that the 2 hours just blows right by, and that we all feel charged and really ready to take on 2021. We also wanted to talk a little bit about this effort that I'm doing. I'm switching hats now to the Better Built Northwest program. And we're going to talk a little bit about this cost per credit calculator because it's really starting to gain some steam out there. And some of you have seen older versions of it. Thank you to those of you that I asked for feedback on. Your feedback was really helpful in developing this into a more robust tool. And I'm about to show you a quick snippet of the tool and walk you through a couple of things about it. But after this, when we send the update, you will get a copy of the cost per credit tool, a really short, like 4-slide PowerPoint that just kind of gives you the basics of how to use the tool, as well as a cost data collection workbook that we're using. So our hope with developing this from Better Built Northwest perspective is to provide something that verifiers, raters, and suppliers can use with their builders to help them best determine what combination of points for Washington State Energy Code could be used to qualify for the code, and associate with that what are the likely costs and some other factors. Our hope is by providing this value to builders, that builders and suppliers are going to be willing to share some cost data back with the Better Built Northwest program. Quality cost data is incredibly helpful, both as codes get developed, as well as for utility programs in order to offer incentives. The less quality our existing cost data is, the more conservative we have to be in terms of our confidence in the savings compared to the costs. So that, that cost effectiveness ratio has to take a discount when we don't have the high quality costs. So this really is highly valuable to both code development and to utility program incentives. What I'm going to show you right now is for Washington State. We are considering, should we come up with something similar for Oregon's energy code. It would be simpler because, of course, it's you don't have quite as complex of an additional measures selection, but it still might be a valuable way to look at this. And yes, so let's just jump right in here. And sorry, I have to move a cat out of the way. Thank you, Hobbs. Okay, so this is what the cost per credit calculator looks like right now. Some of you, again, have seen the earlier version. Please don't stress your eyes out trying to read everything on here. This is just a quick snippet of it. And again, you'll get a full copy of this afterwards. So this tool has some dynamics to it. It allows people at the top to enter what they've been doing for the 2015 Washington State Energy Code and then make their selections for the 2018. When you do that, it gives you an incremental cost difference between your 2015 and your 2018 selections. And that's kind of critical because right now we hear people saying, oh, the new code's going to cost me anywhere from $5,000 to $20,000. And while there may be some truth in some scenarios for that, their existing code selections for 2015 might cost them anywhere from $1,500 to $9,000. So that incremental cost is what we really want people to be thinking about. The current version that we'll be sending around is version 2.0. It starts with the instructions tab, and that's the number one thing we tell people is before you dive into the workbook, read the instructions. They really are designed to be helpful. And we do have to put this little point in. This is a tool designed for education, consulting, and comparison. This is not a decisive price list of measures. That, again, is what we hope to refine with cost data collection. This tool is, again, designed for comparing options for Section 406 of the 2018 Washington State Energy Code, single-family homes. It kind of shows some example packages with credit totals against targets. So, again, if you're a medium-sized home for Washington State, you need 6 credits, and this has kind of a running total as you make your selections. Eventually, up in the upper left-hand corner of your screen, it will turn green for medium-sized homes once you've hit 6 credits. And it shows some example costs per package. It also does some other cool things. We wanted this to not be just about cost. For those who attended some of the Chasing Points webinars we did in late 2020, we found that for a lot of builders, almost equal to first cost, I won't say definitely equal, but almost equal to first cost, are some other considerations, such as what kind of sequencing challenges, what kind of material sourcing, what kind of code concerns, are there any additional benefits, maybe health or durability or comfort associated with some of our selections. And what we've done is we've built some indices in here, some 1 to 10 rankings or scores, if you will. And this allows you to look at a combined scoring metric that takes into account first cost, plus what we call the ease of implementation section. So it allows you to kind of think through packages in different ways and maybe rank them and use this as a discussion tool for a builder to say, can we sell this, right? If we make selection of triple pane windows instead of R4 continuous insulation on walls, is one of those bring additional benefits that we can sell? Maybe it's a durability or resiliency benefit, or maybe it's something that some builders feel we can sell triple pane windows because people can see them, but it's harder to sell a thicker wall because people don't understand it. So this tries to factor a lot of that all into a single tool. Again, our hope is that we provide enough value to the construction market to recruit people to participate in this other cost data collection workbook. So what we really want to know from you is this helpful to you and your builders once you get it? and let us know if you could help us do some cost data collection. So this could be potentially your business does more than verification. Perhaps you also do HVAC or insulation or air sealing or hot water or mechanical. And so potentially you have some cost you could share with us, or perhaps you could work with your builders to encourage them to share costs back with us. So that's a little bit about this. Just we wanted to let you know that this is kind of ready, it's been vetted, and it's starting to go out to the market. And we really want you, our verifiers, field inspectors, and home energy raters, to really have good access to this, learn it, feel comfortable with it, and potentially use it to help us do this cost data collection. So I'm going to pause real quick and let's check to see if any questions have come in. I did forget to mention that early on. Feel free to type in questions in the question box. And as you do, we will check after each little segment for questions and chats. And it looks like nothing new has come in, but I assume that we will get plenty once we are actually sharing this out with you. So feel free, again, when we share the cost per credit tool and the cost data collection workbook, feel free to hit me up if you have any questions on this. So with that, I'm going to turn it over to our good friend John, who's going to talk about Sanden CO2 heat pumps. So John, give me just a second while I now figure out how to give you, here we go. You should now have the ability to drive the presentation. And with that, I'll mute myself until it's time to check for questions for John.
Beautiful. Thanks, Dan. Appreciate that very much. Hopefully everyone can hear me. I did click myself off mute, which I have not done before in the past. So anyway, so yes, thanks to everybody for joining us today, and TRC for organizing this for us. You know, air to water heat pumps, carbon dioxide heat pump water heaters is what we're going to talk about today, and we'll talk about that. I will sort of throw a small scenario in here that we're technically not Sanden anymore. It's a complicated sort of scenario, but I'm actually independent from Sanden, but it's still the same Japanese technology. Sanden is involved in the manufacture of the product. They're much more of an OEM style company than a company that can understand the vagaries of a plumbing wholesale marketplace a million miles from the Tokyo head office. So we are an independent world, and you'll see the product, you know, is sort of a cross brand right now between Sanden and Sanko 2, and eventually it'll all switch to Sanko 2, which obviously you can sort of work out. It's like S-A-N, Sanden. CO2 is CO2 because that's my refrigerant, and hot water naturally is that's because that's what we do. We make the hot water naturally. So without sort of bemoaning the whole thing, we'll sort of dive in here and take a quick look. New product rolling off the shelves almost as we speak. Global supply chain is not exactly being helpful to me, especially with the Rona on here. But you'll see the new product, the GS4 model, definitely some improvements over the GS3 model, but still the same basic scenario is a split system heat pump water heater, or water heater if you want to call it that, or a heat pump, either which way. So the heat pump, what you can see sitting there perched in front of the 3 tank sizes that we'll talk about mostly today on here, is divorced or separated from the tank assembly, which gives you a lot of flexibility in terms of ventilation space. You know, you don't have to have with the hybrid style units where it's all in one, you need to either duct the cold air coming off the heat pump or give it enough space around the heat pump so that doesn't affect your climate inside of the home as it runs. Obviously, that's one of the things. The second thing is noise. The third thing for us is we can make the unit bigger in terms of capacity on the heat pump. So this is a 4.5 kilowatt heat pump. just the same as an electric element, which means we don't need any electric elements on here. So big changes from the old unit, improvements at the DOE test standard efficiency, which we call a UEF, or Uniform Energy Factor. Significant improvements. The 83-gallon tank is almost, it's probably the number 2 heat pump water heater in the marketplace in terms of efficiency, behind the Rheem hybrid unit now, but certainly great efficiency gains at the test standard point here, and also efficiency gains all over in the operation of the unit. Same great performance, because we still have the 150-degree hot water as dictated by the use of the carbon dioxide refrigerant in here. So lots and lots of hot water. That is the number 1 in the heat pump water, or even the electric water heater marketplace. So we have that, and then warranty-wise, the longest and most extensive warranty in the biz, as they say on here. The 83 and 43-gallon tank, still stainless steel. The 119, which is a crossover between commercial and high-use residential, is glass line for us, and obviously has the various certifications. You have questions, throw them in the chat, and we'll either try and get to them now or afterwards on here. Internally, units changed a touch. We've moved some things around, again, in the quest of better performance. One of the things that we've done is beefed up the pump in the unit, which drags the water from the tank to the heat pump and pushes it back when it's been heated at the heat pump in there. That's changed now. It's gone up from 50 feet to 66 feet. The vertical separation has increased as well. We still only need half-inch water lines between the tank and the heat pump. Again, no refrigeration work on here. Carbon dioxide is going to be in a sealed system, so no, you never touch that. It's a double wall heat exchanger. Even though we've changed the design of it, still maintains that double wall heat exchange, so no issues with code. Power supply, 230 volt, 208 volt, single phase, 15 amp only. And that's just wired to the heat pump, the outdoor unit. And then the heat pump has a temperature sensor that is wired between it and the tank, and it basically tells me when the tank is cold, the heat pump starts, and we'll look a little bit in more depth with that. All the connections MPT as befits. To make it easy to install this unit, you literally only need an adjustable wrench and a Phillips head screwdriver, and that's it. Nothing else in terms of a special tool required for us on here. As I said, we live outside, so in the marketplace, that means that we can see a whole range of temperatures from 10, 15 degrees Fahrenheit to 100 degrees Fahrenheit. So the unit has to operate across all of those particular temperatures. And what you see is a flat capacity curve all the way down to about 5 degrees ambient, then dropping off slightly as you go down to the -15s, and then on beyond that. We've done a lot better at reducing that capacity loss on the super cold ambience on here. And then we've increased what we call the COP. The COP is basically how much capacity do you get, how much hot water do you get, versus how much power do you have to give the unit to do that. So day like today, sitting in the northwest right now, we're probably going to be seeing sort of temperatures, in the mid to low 40s, in terms of temperature. So you can just sort of tick over to the 40-degree mark and see that we see a COP of 3.5. What does that mean? Well, if I take my trusty calculator and divide 4.5 kilowatts, which is the amount of capacity we're going to do, by 3.5, that means that the heat pump will be pulling around about 1280 watts to create your hot water, and we're going to create around about 18 to 20 gallons an hour, depending on how cold the inlet water temperature is here. So 20 gallons an hour is going to cost you 1.2, 1.3 kilowatts in that hour. If it's 15 cents a kilowatt, you're talking about 17, 18 cents. As the temperature warms up during the day or into the summer months, that COP gets higher and higher and higher. It means that the power absorbed by the heat pump gets lower and lower as we can take more heat out of the outside air to heat the water. And you can see if we get up to 80 degrees Fahrenheit, we're only pulling 800 watts for my same 18 to 20 gallons an hour of hot water production. And again, this hot water is always going to be either at 145 or 150 degrees Fahrenheit, which means that every gallon that we produce is going to be more at your faucet, at your fixture on these particular units. So schematic and system operation didn't change much from the older unit. Still the same way, the tank independent of the heat pump, water lines 1/2 inch size between the tank and the heat pump. Mixing valve included, has to be installed on these units. Obviously, you don't want to be sending 150 degree water into the building. So the mixing valve to mix down and give you more performance there. Basic operation, use hot water. Cold water comes into the water heater just like any other water heater would do. That cold water comes into the bottom of the tank. It keeps the hot water hot at the top of the tank. There's no mixing inside of there. It's called stratification for us. Eventually, as you use more hot water, the temperature sensor sees the temperature drop, tells the heat pump, hey, time to turn on. The pump inside of the heat pump draws that cold water from the bottom of the tank, heats it to 150, drops it back into the top of the tank. When the tank is full of water and that water coming into the heat pump has actually increased in temperature up to about 126.5 degrees, it will tell the heat pump your job is done, and off you go. And that's very simply, and it just sits around and waits for the next operation. As you can see, it's a system. The tank has got the various little connections inside of it to make it operate at the best efficiency it possibly can. So we don't want you using other tanks on these systems. Come on, advance. There we go. And so we've talked about it before. Okay, how much hot water do you get on these units? So you can see here that if your incoming water is 50 degrees Fahrenheit, and we're making 150 degree water, you're going to make about 18.5 gallons into the tank. Then it will get mixed down at the mixing valve and then mixed again at the outlet or the fixture on here. So typically a mixing valve is going to mix it down to about 120, and then you're going to go down to about 105 degrees at the actual fixture itself. By mixing cold in again and again, which means that every gallon that the heat pump makes and stores in the tank, so that 18.5 gallons that you see being made right now by the heat pump as it's running and consuming its 1.3 kilowatts, actually turns into 1.7 times that. It actually turns into 31 or 30, close to 31.5 gallons at the fixtures. So that's 17, 18, 20 cents of energy that you're spending right now to build that hot water using the heat pump is actually going to give you just over 31 gallons of usable hot water. So you can see that the performance level of this thing is extremely high in terms of that. So you get more hot water for your dollar, and also you get faster recovery of that hot water from this system. So if you've got an 80-gallon tank and you've depleted it completely in your morning use between the entire family, it's going to take around about 3 hours to fill that back up. But in the first hour, you're still going to have 30 gallons available if you want to, wash the cat or whatever you want to try and do here. So great performance out of this, combined with great efficiency on these systems. So how do we look at this in the residential world? I mean, we can also talk about our commercial world, but the residential side of things. Well, that first hour rating is a uniform rating for everybody, and the idea behind it is that it's how much hot water can the unit make in 1 hour. Typically hot water use in a home is bunched. Everyone gets up at 6, 7, whatever, and out the door at 8, or not out the door nowadays. But the hot water usage tends to be bunched and always has been for us all. So that first hour rating is going to be how much hot water can you make. I mean, NEA does also a thing where it is usable showers on here. So I think with our 83 gallon, you have either 6 or 8 usable showers. With the 43, it's 4 or 6 usable showers out of the tank and the system on here. You can install it outside in the snow. It doesn't care. Tank can go tight up in a closet, pretty much zero clearance on here. Heat pump can go into a garage. Garage is, with a 400 square foot garage is actually perfect for one of these units to sit in there, and you also get air conditioning for your garage as well in the summer months. Brackets, the whole nine. We can do all of that. But one of my party tricks on these units is the ability for it to scale. So if you've got a large custom home, where you'd typically be putting in 1 or 2 tankless water heaters, but the guy wants to get off gas, or looks at the energy code and looks at the advantages of heat pump water heaters, and specifically my unit in that marketplace, we can double up on heat pumps, double up on tanks, double up on heat pumps with a single tank. Lots of different ways of doing it, and that will give you more hot water, more recovery. So 2 of those units piped together in parallel will give you, 37 to 40 gallons an hour of recovery on here. 2 tanks like that, 283s piped together, is going to give you 230 gallons of hot water production in that first hour, and then recover in 4 or 5 hours. So you can do lots of different things in terms of the domestic hot water load. We can also go ADU if that seems to be a prevalent thing that's rolling along for us. We can knock those out as well, because the tank doesn't need any space. You can stuff it under a closet. The 43 gallon tank weighs 88 pounds. It's stainless steel and is only 3 foot tall, just over 3 foot 2 inches actually on there. So a great way of doing ADUs or smaller spaces. And then again, we just foster this into the commercial world, more heat pumps, more bigger tanks, etc., etc., etc. One of the other things that's been interesting for us has been, for the last, I want to say 5 years now, spearheaded by Washington State University and the late Ken Eklund, has been the use of the system to give a little bit of heating, right? We make this 150-degree water, right? We have this heat pump that can run down at negative numbers or below 0 numbers. So we have the ability to do some what we call combi in conjunction with the domestic hot water here, about 8,000, 10,000 BTUs of heating in addition to the domestic load. 83 gallon tank minimum, but you could go 119 if you needed. Again, no backup required if the design temperature is going to be above 22 degrees. Below that, we would definitely require full backup on there. Just one of those things that we like to do for our systems on these units. And then, we use what's called a TACO-X block to do the possible non-potable separation on here. That's all set up. We want to send the water out to the emitters to the system as lower temperature as possible, about 130, 135 degrees Fahrenheit, if possible. Again, this is not meant to be a radiator style system. It's not, you can't just rip a boiler out and say, okay, I used to send 180 degree water to the baseboard, I'm going to put this in. It's not really going to work that way. It wants to see radiant. It wants to see a low temperature fan coil or those low temperature decorative radiators that you can get on here. And then, the other thing about the combi, just for the overall efficiency of the system, the more domestic hot water you use, the more efficiency you get. And the reason for that, it's just a weirdness that exists with heat pumps, but specifically my heat pump, my Sanco 2 unit, is that the warmer the water returning to it, the lower the efficiency and lower the capacity on these systems. So using domestic sort of cools down the bottom of the tank and gives me a little bit more performance on here. So that's the combi mode for us. And having just, we've got a quick diagram for you. And again, copies of the presentation, I'm sure, available from Dan and everyone organizing this. And it just shows sort of the way the system's set out on here. So that's the combi mode. Now, if we look at, so let's look at, just some tips and some verification things for you guys as you see these units in here, right? So it's very basic scenarios for us on here. It's really common sense and it's not rocket science. There's lots of technology in the heat pump, but the actual bit that you touch isn't really very difficult in terms of that. So the heat pump, okay, it wants to be level. It doesn't want to be, cocked at an angle. I mean, level is a, as long as it's level on a spirit level, we should be good. Again, just jack it up slightly because, if it does snow, you don't want it to be buried in the snow. 4 to 6 inches behind, 18 to 2 foot in front, condensate piping underneath the unit because it will rip out some moisture on here. So the heat pump, very basic sort of setup. Then piping from the tank to the heat pump to the tank within my required length, obviously, 1/2 inch. I'm very fierce about that, right? It's not like, oh, I'll just put an inch because that's what I got on the truck. It doesn't work that way. As a team of engineers and people that work on these units day in and day out, making them as good as possible here. And then, you want to install it and it's like, 3/4 will do, 1 inch will do. And it's like, you just killed all the work that those guys did, making you the most efficient piece of equipment they possibly could and reliable piece of equipment. So the 1/2 inch is an absolute must. Obviously, we want to insulate that. That water is going to be 150 degrees. You don't need to heat the outside of the world. So 3/4 inch insulation. The only thing that goes from the tank to the heat pump, other than the pipes, is going to be a 16-2 wire. We give you 16 feet on the unit. Power supply for the heat pump, as I said before, 208, 230 volt single phase. Again, it's not a 120 unit. 15 amp double pole breaker, L1, L2, local disconnect adjacent to the heat pump. Again, safety on that one. Got to make sure that we can turn off the power to the heat pump within eyesight of the heat pump. Tank, as I said, can be minimum 0 clearance. The tank is designed for that. All cold water connections at the bottom. So the tank is handed, so it doesn't matter whether it's left or right. But as long as both hots are in the top, both colds are at the bottom, we're in good shape there. On the tank, and that you'll see that's why the tank actually has the same connection sizes for all of the connections. They're all 3/4 inch and need to be nippled down. Expansion tank, it's good plumbing practice. It's code in various areas. It's a good idea, full stop, on there. So that goes on the cold water inlet side to the building, from the building to the unit. And then last but not least, we provide you with the system a Honeywell mixing valve. We use Honeywell. We think it's the best one out there. It's 3/4 inch. It's union. it must be installed. There's no ifs, ands, or buts on this thing. It has to be installed. Otherwise, you're going to get 150 degrees into the building, which is not good for a scald danger point of view on here. So has to be installed. So that's one of the big things to verify on these units. And then temperature set point. The minimum set point on these things are about 113. The maximum is above that. Obviously, we like 120, but local code is going to give you some basics on that as well. And I think you will see more mixing valves coming out on these systems here as they roll on through. Here you can see the basic temperature diagram. It's very simple. Cold comes in the bottom. There's the expansion tank on the unit. Cold goes to the heat pump, comes back from the heat pump. Cold goes out to the mixing valve. The hot goes to the mixing valve. Cold goes to the mixing valve, and the mixed outlet to the shower and whatever. So very straightforward, very simple and easy to pipe. Lots of technology inside, but away you go from there. Obviously, one of the things that we've seen in the last few years is the rise of recirculation, whether it's a dedicated recirc system or it's I'm going to stick this under the last fixture and blow the hot water back through the cold lines into the tank on here. The big thing is, it doesn't really matter which way you want to roll with it, is control. Don't just set your pump to run. Have it set up so that the pump cycles on and off, and actually quite frequently, to be honest with you, whether it's a sensor or it's an aquastat or even if it's a timer. Most of the jobs you guys are going to see is we've probably got 200 feet tops of recirculation or hot water line to clear in there. Even if it's 3/4 inch, we're not looking at more than a gallon and a half of water in that particular line. These pumps are rolling along at 3 or 4 gallons a minute, or even more in some cases. So if I want to clear a gallon of cold plug through the system, well, it's not going to take me at 4 gallons a minute, 5 gallons a minute. It's not going to take me more than 15, 20 seconds to do that. I don't need to run that recirculation pump for 15 minutes. It's just a colossal waste of energy. You're just drawing hot water out of the tank just for the hell of it. And it just really doesn't make any sense whatsoever. So recirculation is definitely something that we don't need to dwell on it too long. Important to have it to run, but not to run too long on these systems. And here's a quick diagram of the recirc. So you've just taken that basic standard diagram. I kept the expansion tank, moved it slightly, but yeah, no big deal, right? And what you can see is cold water comes in just like the old one. Cold goes to the heat pump, hot comes back. On the outlet, it goes to the mixing valve. You've got cold going to the mixing valve there. The only change is that dedicated recirc line. There's the pump. There's the aquastat controlling it or sensor. Check valve on one side. We've got some water going to the mixing valve. May as well use it. We've got it in the system. It's, otherwise we're going to just send it all back to the tank. And then you've got the other check valve to make sure the water actually goes in the right direction. And then it hives off and pushes some down into the storage tank. Very simple, easy diagram for everybody to look at. We've worked on it, and it reduces things like temperature creep and all those sort of things as the recirc pumps operate, and there's no domestic being drawn on these systems, so it helps the mixing valve operate on here. So it's nice and easy on these systems. Last but not least, on sort of the installation side of things, yes, I know hot water is outside. It's scary. Definitely scary. So a couple of ways we do it. One, you've got to trace heat the lines if it's below 27 degrees on the design ambient. We offer and this is an off-the-shelf kit, Raychem Frost Guard. You're going to wrap it on there. It's self-regulating, so it doesn't have another thermostat attached to it. It actually regulates the amount of heat based on the contact temperature of the pipe. So when the pipe's hot, doesn't give up much heat. When the pipe's cold, it gives off the 8 watts per foot, which is minimal at 230 volt power. I mean, this thing only is going to pull about 0.2 amps on here. Then everyone says, okay, great, Tracy, I get that, but the power's going to go out. The power's going to go out. It's going to be a disaster. The water's going to freeze. And then what we have is this ingenious little valve setup where these valves have a temperature actuating control in them, and they actually act like a frost-free hose bib. And what they will do is slightly open if the temperature and the water temperature gets below about 35 degrees Fahrenheit. That will sort of allow the water to move around the system. Yes, it will drain out outside a little bit, but it will allow the water to move around the system. Stagnant water is a freeze issue. Moving water isn't. That's why, when you look at the river, most of the time you're not going to see ice all over the river unless it's absolutely frozen out there. So we have those two particular options available for us. So verification on the installation, which is your sort of thing, right? My 8 basic requirements that we talked about, are they complied with? Pretty straightforward. Piping, is it to my drawings, domestic and combi? Have we followed all the normal plumbing codes and practices, right? I mean, basic, everything's tight, it's not leaking, Is my electrical wiring to code? But, typically, my unit's going to be to code. Make sure we've got my local disconnect in there. The field wiring from the breaker to the disconnect, that's going to be based off the length and volt drop there. So we're going to make sure that's sized correctly to code. Then when the unit works, water temperature from heat pump to the tank should be over 140. As you look at that, water temperature from the tank to the mixing valve, that small section, of the hot water coming out of the tank, that should also be around about 140 degrees in there. And then last but not least, is the water temperature at the fixture acceptable for end use and occupant health, right? And last but not least, a quiet unit and a vibration-free unit is a happy unit. So we're going to sort of roll with that on there. So that's your verification. Again, not an onerous task, but again, this is a simple installation. We have a YouTube video you can go find on our YouTube channel of me putting the unit in Oregon and rolling along with it. So that's always there to help out on these particular things. That's pretty much my my role here. My website, eco2waterheater.com. Obviously, we do some of the social media, the YouTube. We're going to put a few more things in there. And then last but not least, at the end, is going to be my contact info, my email, john.miles@eco2systemsllc.com, and my number if you want to call or get hold of me that way. So happy to answer any questions if anyone's thrown anything in the chat, but I appreciate the opportunity to talk to you guys, and I will leave it there.
Thank you, John. And we do have some questions that have come in. Some of them came in and you answered them almost immediately after, which is just good timing and good presentation. But let's go through a couple of these questions, if you don't mind. A few months ago, we had someone present on NIA's advanced water heater specification. So the first question is, do these Senko 2 units qualify for the Tier 4 of the advanced water heater specification?
Right now, we're at Tier 3, simply because we have not finalized our CTA 2045 interface with us, right? So as soon as we've got the interface, which I am hoping will be, within the month here, we will jump up to Tier 4.
Great. And the importance of that locally is that Tier 3 gives you 2 points in the Washington State Energy Code, whereas Tier 4 gets you 2.5 points. So it's a help to builders. So semi-related to that is, do these units have any sort of Wi-Fi compatibility or other communication strategy that would allow them to participate in the demand response programs, or to be controlled by an app, or to fit into an energy smart home?
Yeah, so I mean, we will have the CTA 2045 system up and running. You know, I believe that is going to be available via an app or via a thing to be able to communicate to the unit on Wi-Fi. But don't quote me exactly right now. We're just going through this is a third-party thing. CTA 2045 doesn't exist in Japan. Japan takes a very holistic view of control over the system, where it's more of a whole house thing. They call it HEMS, home energy something or other. So the systems run a little bit differently to that. So we're just trying to sort of, you know, deal with all these variant types of ways of controlling the unit. So the CTA 2045 will be a module that hooks onto the tank. It's completely retrofittable to the unit, and then it interfaces with my unit on a slightly different way. And how you interface with the CTA 2045, I'm still a little blurry on that, because the guy starts talking all sorts of IPs and stuff like that. My eyes glaze over, you know.
Fair enough. If you were using this for the space heat, can you use a smart thermostat, a Nest or an Ecobee, to control it? Or is there a proprietary thermostat that you would need to use?
No. Any thermostat works fine with it. As long as it's got a 24-volt signal, it's good to go. Great.
And finally, you've got your email address up here, the website. If a verifier or home energy rater has a builder or an installer who's really interested in learning more about this, I assume they can reach out to you directly for support?
Yeah, just flick me an email or a call or whatever, and I'm happy to help and provide all the resources that we have.
And then finally, just more of a statement. Jamie Faraday, thank Jamie for piping in here, has a very low load home with an energy recovery ventilator out on the coast that had one of these installed over a year ago for space heat and domestic hot water. And the homeowners absolutely love it. The temperature has always been exactly what they expect, and they really, really like the fact that it's so quiet with the outdoor pump. So that's kind of a local nod to the fact that we've seen some of these come through, and people are already very, very happy with them. So, John, thank you so much for this presentation. Again, we will be sharing all this information out with folks. And I did have somebody say, boy, this is a lot of information. And the answer is yes, it certainly is. It's because this is new and different for a lot of people. So you'll have a copy of this. You can share that PDF and sit down with your builders and talk about it with them, but you can always reach out to John if you're really in that position where, all right, we need to really nail this down and talk this through with the builder. Reach out to John. We're not expecting you as verifiers and raters to become complete experts on these, but we want you to have enough to be able to speak about it intelligently and direct people, you know, whether it's a decent or not decent option. And I think in most cases, especially for domestic hot water, it's a really good option. Combi system might be a little different depending on where you're at, but yeah, reach out to John if you have questions. So John, thank you so much. And just for time's sake, we're going to keep on moving here. Next up, Anna is going to talk on the runway. So she's going to talk a little bit about energy modeling, in particular around balanced ventilation and HRVs, as well as a few other things. So Anna, I'm going to give you control. And you should be able to drive now, and I'll mute myself, and we'll be checking for questions as they come in.
Great, thank you. I will go to the next slide, I think. Okay, there we go. We have had questions surrounding balanced ventilation systems lately, so we wanted to do a quick review of how to model these systems in different scenarios that arise. I'll begin with a review of the basics and jump into the areas where more questions arise after that. The modeled ventilation rate should be accurate to the operating conditions of the system installed. And in both Oregon and Washington, the ventilation rate should meet a minimum of the ASHRAE 62.2 2010. We highly recommend working with your builder to ensure balanced ventilation covers the entire CFM requirement. This is a best practice, and if you're running into concerns with your builders in achieving the minimal ventilation rate with the balanced system, please reach out to your Verifier account manager, and we can talk about different options. So I'll go to the next slide. This one has a lot of words on it. We aren't going to read over the whole thing. I just wanted to point out that balanced ventilation is in the Northwest modeling requirements, and draw attention to the fact that they call out the Home Ventilating Institute tested ASRE and HVI tested fan watts. And so I am going to show you what that looks like. Here we are at the HVI website. You follow the URL listed on the page, and for balanced systems, click on the Section 3 directory. Again, most of this will be some review, and we'll jump into more complicated things here in a minute. So when you click on Section 3 directory, it will bring you to a page with the table on top, which you can filter down with brand name and system types. When you find the system you're looking for, you can click on more details, and the table on the bottom pops up. So in this slide, we're looking at the Brown HRV80. The fan is operating at 47 CFM or lower. You would want to use the ASRE and watts in the first row of that bottom table. And then if the fan is operating between 48 and 61 CFM, you would use the tested 48 watts and 68 ASRE in the table below. But what if your fan is operating above 61 CFM? So I'm clicking here. If we go back to the table on the top, the first page that pulls up when you click on directory 3, you will see there's an HVI tested net supply at 72 CFM. And our program will allow for you to go up to the net supply CFM if your fan is operating above the net airflow. So if your fan is operating between 61 CFM or 72 CFM, we will let you go up to that net supply. All right, a true operating, the ASRE related to the highest net airflow at 32 degrees Fahrenheit is what should be used, and the associated watts with that ASRE should be used. So you can go up to 72 CFM and then use the ASRE of 68 and the power consumed of 48 watts. And while our program would encourage you to not max out the fan CFM like this, we understand that suppliers and code utilize the net supply, and this allowance may be necessary for situations that verifiers encounter. So to the next slide, finally, what if your balance system is not meeting ASHRAE 62.2 2010? I want to mention again that we highly recommend working with your builder to ensure balanced ventilation covers the entire CFM requirement, as this is the best practice, and reaching out to your account manager, Verifier account manager, can help navigate different situations to avoid this. With that said, we do have situations, most often with one-off homes or owner builders, where the balance system is not meeting the CFM requirements, and the remaining CFM is captured through exhaust ventilation. So in this case, please model the systems as listed here. So the balanced, we'll use, here I'll go to the next slide. The type should be balanced. The ASRE should be appropriate for the balanced system. The CFM rate should be the continuous ventilation as calculated per ASHRAE 6222.10. The hours per day should be 24, and the fan watts should be the balanced system watts plus the exhaust ventilation watts. The access checklist will ask for the model number of the balance system, and then please enter the model number for the exhaust system in the notes section of the checklist. Then please note the exhaust ventilation system must still meet the relevant field requirements, including either the 24-hour operation or the related requirements for intermittent ventilation systems. And then finally with Ecotrope, allows multiple systems, so we don't need to jump into how to do that in Ecotrope. You just model the two different fans separately. So that's it. If there's any questions, I can help answer, or if we need to wait till the end, that's fine too.
Thank you, Anna. No new questions, but I did want to reaffirm what Anna had said there about our program really does recommend hitting the entire ventilation rate with a balanced system, keeping in mind the energy codes that are changing. In Washington State, if you do not deliver all of the house CFM with balanced ventilation, then you actually get penalized and you have to deliver more ventilation. So it's a kind of a vicious circle in Washington State. In Oregon, of course, starting in October, you'll be required to do it with balanced ventilation. So start thinking about this now. Work with your builders on planning around balanced ventilation. In Oregon, come October, that's going to be mandatory. In Washington State, it's almost mandatory. You will be penalized with either a 25, you'll either need to do 125 or 150% of the ASHRAE rate if you're not doing balanced, distributed, and continuous ventilation. So that is important to note. If you have questions, feel free to ping us afterwards and we will be happy to help out. Let's talk a little bit about some training items that are coming up. First is Build Right is coming. April 21st and 22nd. It will be an online session only. If you click on the Build Right, you see it underlined at the top. That's the link that'll take you to the Build Right website from the HBA. They are going to have CCB credits. They're using a Zoom functionality here, so it's going to be the kind of stuff that you're familiar with technology-wise. Some of the session highlights, we're going to see some high-performance, cost-effective air barrier details. We're going to see stuff about, what's new in the era of COVID-19. How has that changed construction? We're going to hear about disruptions to the industry in a keynote. There's going to be a lot of, and probably several sessions around codes. So there should be a lot there really valuable to you. And in our grand tradition, we actually are the Energy Trust and the EPS New Construction Program really also would like you to go to this. And if you're interested, guess what? You can use the promo code 21TradeAlly, all one word, and it's free. Just because it's free, we do encourage you to still let them know when you go through the registration whether or not you're a member of the HBA. This helps them track, are members attending our conference, non-members, what's that balance? So it helps them think and plan and do outreach moving forward. If you also happen to be a presenter, I know there's a few of us that are both presenters and trade allies. You do not need to register separately. The team at the HBA will be working directly with you, so you won't need to use that promo code. They'll work directly with you on the registration. If you have questions, Greg Lasher from our team, one of our Verifier account managers, manages our relationship with the HBA, and he's happy to help you out, and his email is right there at the bottom. The other big thing coming up is we have Chasing Opportunities in Energy Code, an Oregon Homebuilder Roundtable webinar coming up April 14th. If you attend any of the Chasing Points we did in Washington, it's going to be a little bit like that, but of course focused on the Oregon Residential Specialty Code coming up. Based on this feedback and from this roundtable and your interactions with builders, we'll be hosting a second one a little bit later in the year, most likely near October. So there is an invite, and guess what? It's right here. You click on this register here link. It will pop up and you can register directly for this training. We're going to do some deep dives into Oregon code, things like getting the heating and cooling system and distribution inside of the heated envelope. We'll talk a lot more about balanced ventilation and some of the major and additional code changes. So there's small language around pipe insulation, et cetera. But we're really going to cover the big stuff. We're going to cover the additional measures, getting the heating and cooling ductwork and systems inside the envelope and balanced ventilation. So we're really excited about this. We hope you're excited about it too. please reach out to us if you have questions about this builder roundtable. We will be doing some direct outreach to builders, but we hope that you will as well reach out to your builders and encourage them to attend this. It's part of our mission is to really make sure we've got a really good finger on the pulse of the construction industry, and it's more than just talking to you all. You are terrific advocates for our program and for energy efficiency in new construction, but we also want to make sure that builders get a chance to hear from us directly a few times a year as well. So it's really important. We think this is a big deal. Please help us out with some outreach and recruitment if you don't mind. And with that, look at that, right on the hour, and we are all done. I am checking and don't see any new questions that have come in. If you have any, we'll stay on for a few more minutes. Of course, by next Wednesday, we will have this follow-up email out to you. It will include John's presentation, Anna's presentation, these live links for the trainings, and of course, the cost per credit calculator and cost data workbook. So please keep your eyes peeled for that. And as usual, thank you so much. We understand your time is valuable. We really greatly appreciate it, and we love spending an hour with you every month. So thank you very much for attending. If I don't talk to you before then, I will talk to you next month at the annual Verifier meeting. All right, thank you, everyone.